for the
Yes,
TV.
and I'll share you
Um,
through my YouTube channel as unlisted. So any other people cannot see this. Only those who are having the link can see this. Okay. So we'll
okay.
start here now with the effect of coal physical uh, properties, physical and chemical properties. Let me just, yeah. Okay. So this is again an insight to coal quality assessment. What we know is that coal is a very heterogeneous matter, okay, which contains organic matter, ash, then from decomposition of mineral matter, we'll get ash and mineral matters. Mineral matter may contain calcium, magnesium, silica, alumina, other things. And then we have got volatile matter, which mainly contains methane, but there are other propane or other gases are also there, because coal bed methane does not only contain methane, it also contains higher hydrocarbons. And then we have the moisture, which is moisture is in two state. One is on the surface and another is the inherent moisture. So in this slide you can see here that what we do actually, mineral matter is very important for us to understand its property within the boiler. Even for the one is your slag formation, slagging, and another is fouling. Coal in dry state will contain still organic matter and some volatile matter. Then after air drying, it may contain volatile matter, organic matter, mineral matter, plus inherent moisture. So that is what is written here: C plus H plus O plus carbon, hydrogen, oxygen, nitrogen, sulfur, ash, and some water. That is in dry state. And in raw state, when you receive it, it may contain the surface moisture as well. If you see moisture we take out at 105 degrees centigrade, organic matter which may contain uh, some volatile matter plus elemental carbon. Now there are two carbons, one which is associated with volatile matters like methane, and some which are elemental carbon inside the coal. So that contains carbon, one in two states, then hydrogen. Hydrogen mostly we'll see uh, 50% of that in as gas, not as associated with carbon. Then oxygen, nitrogen, sulfur, and some wittenite matter, which actually gives a kind of slagging index to the uh, coal, then oxygen, and then you got in ash, you have got silica, alumina, calcium, magnesium, iron, carbon. Iron is mostly in pyritic state, sulfur, etc. Pyritic means FeS, iron and sulfur together. So that contains the ash, and here from this uh, slide you can understand what is coal. Still, nobody in the world knows complete coal chemistry. Different coal have different chemistry and different structures, different C and O bonds, C and H bonds. So coal is a very heterogeneous matter. Now, we do stone assessment. I can come at a later stage on this, but let me first tell you the calculations for the combustion. The properties, which property gives you more calorific value, which gives lesser kilocalorific value, and all those things. So, the theory is here. I'll expand this,
Yeah.
and yeah, surely I'll expand this. I hope you can see this now.
Yes. Yes.
Okay. So from here you can understand carbon plus oxygen gives CO2 if it is complete combustion and gives you 327.7 uh, megajoules. Then oxygen gives you a lot. Even 2H2 plus O2 gives 2H2O. Though there is some loss due to the H2O formation, but the amount of energy given by hydrogen is very high, 525.4 megajoules. And sulfur also gives you some amount of energy, but not significant enough, becomes SO2 and gives you 26.9 megajoules. If carbon is partially combusted, means it is not fully combusted, the oxygen is not complete in the boiler, then CO will form, carbon monoxide will form, and give you 112 megajoules. I, in one Excel sheet later, you will see I've converted all these things into kilocalories as well. So this is the theory which gives you. Then if I burn CO, like you see the blast furnace gases and coke oven gases, when they are burnt in HRSGs in steel plants, they give complete combustion CO2, and they still give you 260.7 megajoules. So this is in comparison 327.7 as compared to 260. The composition of standard dry air is the density is 1.293 at standard temperature pressure, as we know. Nitrogen, oxygen, argon, CO2, these are available in mole fractions. And that is how we calculate how much oxygen is required to, you know, how much air is required to do this complete combustion. So this means 12 kg of carbon burns with 32 kg of oxygen and gives 105.6 kg of N2 to form 44. Now, from where this N2 has come? It has come from this constituents of air.
Yeah.
Yeah. And it forms 44 kg of carbon dioxide and 105 kg of nitrogen. While it liberates 372.7 megajoules of heat. Detailed calculation for air requirement is given here, which you can understand very well. If suppose my kg constituents per kg of fuel, if moisture is 18%, it is 0.18 kg per kg of fuel. Ash, if it is 8%, it is zero point zero 0.08. Carbon, if it is 59%, it is 0.59. Like this, it goes. And in that Excel sheet, which I'm going to show you in the next attempt after this PDF, you will be able to find all these calculations being done in the Excel sheet with the formula. And I'll supply you that Excel sheet with the formula so that you can always take the uh, uh, that coal analysis, ultimate analysis, and you can do this calculations. Now, here it is written as one of elemental carbon. If carbon is there, then how much oxygen is required, how much nitrogen is required total, how much air is required, and how much CO2 will be produced. If complete combustion is there, this is incomplete combustion. C double two is 1.33 oxygen, 4.43 nitrogen, 5.76 air will be required, and CO will be produced at 2.33. Hydrogen, if 8 hydrogen is there as above it is shown, then it will take 26.38 nitrogen, it will give you 34.38 air. So what is important over here in these slides, in this theory, is that your major energy comes out of carbon and hydrogen from the coal. So when I go into the Excel sheet, you will see how much kilocalories. And if we can change that, if you have some data, we can change that and we can find out how much it goes. Then after hydrogen, sulfur, one sulfur will give will take 3.32, sorry, will take one oxygen. One sulfur will take one oxygen and 3.32 of nitrogen, and will give you 4.32, the total 4.32 of air, and SO2 will form as 2. So these calculations has been done, how much oxygen required and how much kg, this is produced, and then the mineral matter is coming into place. Here, the amount of oxygen, mm is the mineral matter. It is necessary to correct the ash to mineral matter. So 1.10 ash, 1.10 into ash plus 0.53 sulfur plus 0.74 CO2 minus 32 will be the mineral matter. As you saw in the earlier slides, there was mineral matter written in two of the slides. Like this, here, if we calculate, it comes to 9.38% as mineral matter. Now, similar things we have calculated, and we have also got the calculation for the composition of waste gas. How much waste gas we are going to produce? How much H2O is there in the coal? How much moisture is there in the coal? And how much H2O is produced due to the hydrogen? That is also calculated. So let me go to the Excel sheet where I hope that you will be able to understand much better. Yeah, here it is. And what I will do is I'll again increase the font size a bit. It is at 120. So you tell me, sir, when you are able to see it or not.
Yeah, it's okay.
No, it is okay, but it's going towards right direction. Just a moment. I'll reduce it to 140 and see what fits. Fit selection. That is the best. No,
Mhm.
it went away. Okay. Still not there. 130 would do. I hope this should do. Yeah,
Yeah, it's visible, but is this one column is very big. That is all creating this all column.
correct, sir. So actually, this is Excel sheet made from. Now I think it will be visible to you and also complete. Right.
Yes, yes.
So this is from actual coal data. If I calculate this, then this is what I get. 12 This 12 kg CO2 combines with oxygen, gives CO2 and gives you this much of energy. So if I do into kilocalories, if you have the coal data in front of you, any data, or if you remember the data, how much carbon percentage, hydrogen percentage, so we can very well do the calculations and find out how much kilocalorie it may contain. Okay, like if it is having 42%, and if hydrogen is say around 3.5%, then you may be ending up with 4214 kilocalories. So sulfur also plays a little important role. So sulfur, if I make it 2, then it is slightly increased. Now for that, how much air is required is mentioned here. Now this carbon on complete combustion will require 2.67 of oxygen, 8.7 of nitrogen. Total air requirement will be 11.37. The CO2 produced would be 3.66 in complete combustion. Hydrogen, similar thing. Here you can see hydrogen is giving quite a lot of a big number. Not only carbon, but also hydrogen is giving a big number. If you just alter this a little bit, say 39%, and this into 2%, it drops down to 3524, the kilocalories. Now, amount of air required would be calculated from this. Sir, you may ask any question anytime. Okay,
Sure,
there is
sure.
there is no hindrance anywhere. So the amount of air which is required for this combustion is calculated from here. From this table, we have taken it. So amount of air required can now be calculated analysis from the table as follows. So 1.047. So 2.67 into 0.39 kg of carbon will require 1.040. So theoretically, you will, if you try to do a combustion of this three, carbon, hydrogen, sulfur, theoretically you would require 1.22 kg of oxygen. The amount of O2 in the fuel, it should be deducted. So whatever fuel is O2 is there in the fuel, that should be deducted from it. So oxygen here, oxygen 8.85, that is deducted from here, and you get 1.13, 1.1315. And the corrected O2 for the fuel, total volume required would be 1.22, less O2 content in the fuel, 1.14. This O2 content of D79 I've taken. D79 is below. I'll tell you why I've taken this. Here, the moisture, ash, carbon, and here oxygen is the balance. When we do the mineral matter, to be more precise, it is necessary to correct the ash mineral matter. When you do the mineral matter will come, in this case, is coming to 41.28. If you do the mineral matter correction, then you will get balance oxygen as 7.78. Oxygen is always the balance, even in case of our proximate analysis, ultimate analysis, it is the balance. So that balance is getting reduced here. 1.1422 oxygen is required. You include 3.5% excess air, it becomes 5.11. So volume of air at STP would be 3.95. Now, from this Excel sheet itself, you can calculate the waste gases, what could be produced, and the volume of the gases at normal temperature pressure and at standard temperature pressure. Both are available here. You can see, and everything is having formula inside. So it's not difficult for you to find out, how much what we are doing and what we are not doing. So this will be supplied with the formula to you so that whenever you have the access to your ultimate analysis, you can go with the uh, this Excel sheet. You can calculate the things with this Excel sheet. So now Avogadro's hypothesis, which states that uh, that 1 kg of any gas will occupy 22.41 meter cube at STP. The above computation uses the specific volume of each gas. So each gas is each gas are having its own specific volume, and accordingly the coal per hour, this much coal per hour, if you change this as per your this thing, say you need uh 20,000, so it will give so much of SO2 in the volume and so much flue gas in totality. So you change your coal characteristics inside wherever it is not having formula. You just put on your data, and there are two sheets. One is uh, for LPGCL. I've designed on the coal. No, for LPGCL, I've done it on the design coal, and from actual coal analysis, you can find out here. Both are open formula. Both are open things. Here you have to put the data, and most of your data will change below. All right. If you have any questions, please go ahead, or else I'll close this Excel sheet.
That's okay. This Excel sheet you are giving to us, na?
Sure, sir. Why not? It is my duty to uh, give knowledge. I'm running a knowledge company, and
Yes.
this is what I give to my customer, which is called knowledge. If you have knowledge, you can make your things better in your system, and you will always give me a pride that I had been supporting Domino's Pizza, which I eat every week, a company from which Domino Pizza comes.
It's good if you can digest.
I do, I do, but it's a weekly thing, so digestion is not a problem. But anyway, you are also manufacturing chemicals, so let me know what chemicals you are manufacturing, because we are now opening one chemizone, like Amazon. We are opening one chemizone, so we'll be selling a lot of chemicals from that website. So should I close this Excel sheet? Uh, was it difficult to understand?
That's okay.
It's okay.
Okay. So you can calculate the kilocalories from here. You change this and you can calculate the kilocalories here. Right, sir?
Yeah.
Yes.
Okay. Now we'll go into the effects of these parameters. There are sensors to optimize combustion. I think you all know that there are oxygen sensors available. You may be already having it in your boilers, oxygen sensors at the economizer inlet or outlets.
Outland.
Yeah, and that helps you do the combustion properly. Now we'll go to the coal physical and chemical parameters, its effect on the boiler. Now, one is transportation of coal. Now, the transportation of coal uh, is a big matter in India, and lot of people like Vedanta, Tata Power, Mathan, and also some like GITPL, they're suffering of this transportation of coal, and that is why we are into the market with our IT CMS, which manages the coal from cradle to the grave. So transportation of coal influences the system. Then storage of coal. Storage of coal is one of the very important thing which we will be talking in the next session of the slide, means today only, next session of the slides. Then design of boiler. How does it affect the design of the boiler? If the design of the boiler is a different coal and your coal actual what we are getting is different, then the behavior would be different. Then combustion performance. CFBC, AFBC will have different combustion performance. Pulverized fuel boilers will have different combustion performance based on what is there in the coal. What are those properties? Mill performance, if you have mills, then mill performance also will depend on the coal property, especially its hard groove index and the losses, performance of boiler and losses due to moisture in the fuel, losses due to moisture formed of out of hydrogen on the fuel, and finally the slagging and fouling index. It's like sometimes it slags in the bottom itself, and sometimes it slags at the topmost area where the highest temperature exists with the ash. So first we are going to take so fixed
But this
carbon.
lagging and fouling problems normally take place in PF boiler.
Yes, sir. It takes place in PF boiler, but in Aditya Birla itself, I've seen some of their bottom portion are getting slagged. Okay,
That's a
because of
CFBC boiler or PF boiler?
CFBC, sir.
Achha. They are using the Indian coal or imported coal?
Imported, sir. That's why. That is the
Achha,
problem
achha.
actually.
Achha, achha.
So the VM goes out, sir, actually. So the remaining carbon becomes char, and that charring is the problem there. That is like slagging inside the bottom place. So now we are going to talk about the fixed carbon which you get from uh, your analysis. This gives you a rough estimate of heating value. You have seen in the Excel sheet, which I'm going to supply you. I'm going to supply you both theory and Excel sheet so that you can match anywhere you have any doubt. You can come back to me. So this gives you a rough estimate of heating value of the coal in kilocalories. The second one is volatile matter. Volatile matter is an index of gaseous fuel present in the coal, and this typically ranges between 20 to 35. If it proportionality increases the flame length, helps in easier ignition of the coal, and we all know that there is one formula called F3 upon Vm. So that is
Yes.
also set. That is also set due to this because burning of a coal is helped by this availability of VM, volatile matter. It sets off the minimum limit of furnace height and volume, and much deviation from the designed coal should always be avoided because then your flame length will not be as per your requirement. The furnace height will be, will not be as per the coal combustion requirement, or coal will behave differently in a different set of conditions.
Yeah, just one question. Suppose because whatever coal we are getting, imported coal we are getting at 2 units, that is at Nira and Bharuch, the volatile matter is working out to be above between 25 to 35%.
Hmm.
So I just wanted to ask, is secondary air requirement is there or no? Because in the existing boiler, we don't have secondary air requirement.
No, secondary air requirement is not there, sir.
Achha, we don't
Because
need to go for secondary air.
no, it's because you have already, combustion has started from the bottom, and the volatile matter would be burning right to the top. Okay, so air requirement as per the carbon present, as per the ultimate analysis, what is the carbon present, that would be supplied through the primary air itself.
But the unburned carbon, what we are getting is very high because we are getting unburned carbon above 18 to 20%.
Normally in CFBC boilers, you get 18 to
No,
20%.
whatever boilers we are operating here, these are all AFBC boilers. We don't have CFBC boilers.
Then you can try a secondary air because then unburned carbon may be because of lack of air. So that is also a very important factor which I saw in
Mhm.
Vikram Cement. In Vikram
Mhm.
Cement, I saw this factor that their air was more circulating in the bed itself. It wasn't uh, going up with the volatile matter to get the volatile matter also burned. So they had this
Mhm.
challenge of high carbon. So
Mhm.
you may increase, you may try with secondary air, but normally in CFBC boiler secondary air is avoided. But since you are
No, no, in
using,
CFBC boilers, secondary air provision is already given. But in
hmm,
AFBC boilers, normally these old boilers, no, which are very
hmm,
old ones about that are about 10 years and past, they
hmm,
don't have these secondary air provisions. So at NIRA, we are facing this challenge of high unburned carbon. And we
hmm.
are using their imported coal and which has volatile matter between 30 to 35 percentage.
Yeah, and that is why you see uh, in the last line I've written influences secondary air requirement and distribution aspects. The volatile
Mhm.
matter is deviating from the design, then it influences the secondary air requirement and distribution aspects. Because I'm not gone into the depth of your boilers and I don't know the design, I cannot really comment on the requirements unless until I see them. Okay, until I see those things. But you are quite experienced actually, Jena sir. You know the operations aspects particularly. So
Yes, yes.
when the unburned carbon is high, actually unburned carbon, is it a charred carbon or is it a very minute particulate carbon, that we have to assess, because if
No,
it is
it is a
VM,
particulate carbon, not charred carbon. It is a particulate carbon.
okay, then you may have to increase the secondary air. But first try it once or twice, then go for it. If it
Okay.
is low, then it influences secondary oil support.
Okay.
So fixed carbon and volatile matter provides an insight into the reactivity of coal. FC upon VM ratio, which is also known as fuel ratio, that indicate the combustion characteristic of the coal. When the ratio is more than 1.5, combustion would be difficult. Is it so in your coal? FC
No, that
upon
is not
VM.
an issue. No, no.
If the ratio is less than 1.5, it is easy to burn. The imported coal with higher volatile matter actually requires very careful handling, particularly in summer, as it prone to catch fire. Lower mill outlet temperatures, as in PF boilers, mill outlet temperatures, we have got many mill blasts due to
Yes,
this.
yes.
Yeah. So lower mill outlet temperatures are required, need to be maintained as compared to 75 to 90-degree temperature with our indigenous coal. Thus, when we are firing blended coal having a component of high volatile matter, mill inlet temperature has to be maintained carefully to avoid any mill blast or fire. In Adani Power, when I was working in 11-12, there were many instances of mill blasts.
It's like they reduce the temperature, no? Mill outlet temperature. Normally they keep it maximum at 120 degrees maximum. तो उसके बाद वो प्रॉब्लम होना चालू होता है, मिल ब्लास्ट होना चालू हो जाता
Yes, sir. Yes, absolutely correct. Now, the ash content. Ash is an impurity that will not burn. This typically ranges 5 to 40%. Now, what is ash actually? Ash is nothing but uh, the soil which got buried with the plants or trees. Coal is actually made out of the trees, right? Right? The vegetations. Vegetation buried under the ground in earlier era, in becomes coal, and the soil surrounding that uh, plant or tree, that becomes the ash. So that typically ranges from 5 to 40%. It depends on the uh, cleaning and washing of coal as well. Ash reduces the handling and burning capacity, increases handling cost, and affects the combustion efficiency and boiler efficiency. Now, in the next thing, I'll tell you that there are two components, sulfur and ash. They do not go away during the storage. So suppose we have 40% ash in coal, we have say 20% ash in the coal, and the volatile matter which was there in kgs, say some 25%, that becomes 15%, and the fixed carbon and the carbon which was there, that also reduces by 10%. Overall 25% reduction. So 1 kg will become 0.75 kg. So now the percentage wise, the coal sulfur and coal ash will increase because they will remain constant. Suppose that was 20 upon 1 kg, 20% of 1 kg, that will become 20% of 7, uh, 0.75, uh, 1 upon 0.75 into 20%. So that increases.
Yes.
Now, moisture content. Moisture in the coal, it must be transported, handled, and stored. It decreases the heat content per kg of coal. Typically ranges between 0.5 to 10% in Indian coal, but in foreign coal, it may go up to 30% to 35% because that has to be transported in ships, in vessels, and that vessel will contain. Indranil, can you talk about what you see in Visakhapatnam and Krishnapatnam port? How much moisture you see?
Uh, Actually, sir, in typically, if you are talking about the imported coal,
Hmm.
the total moisture is around 30 to 40%. If imported coal, I'm talking about mainly for the South African coal,
Okay.
Indonesian coal. Sorry,
Hmm.
30
Because
Okay.
to
whatever, even
40%.
we too are getting imported coal from Indonesia, we too are getting almost 30 on an average 35 to 40% this moisture percentage we are getting.
Moisture. Yeah. Okay.
Hmm. So
So,
moisture. Huh.
so
Yes.
in compared to South African coal, Indonesian coal is having higher moisture, but in case of South African coal, the moisture is very low. In around it is around 10 to 15%.
Okay. And this moisture increases the heat loss due to the evaporation, which is the latent heat of evaporation is taken away from the kilocalories which carbon and hydrogen could have produced. From that, the latent heat of evaporation has been taken away by this moisture from the boiler, and thus the boiler efficiency reduces. So that is one of the important point which we need to keep in our mind. Now we are paying kilocalories, rupees per kilocalorie, right? If we are paying rupees per kilocalorie, that is fine. But you also keep in your mind that this moisture is going to take away your rupees per kilocalorie also higher because that is taking the latent heat of evaporation away from your boiler, and that helps to limit in binding fines, aids radiant heat transfer. This aids the radiation heat transfer, and it also helps in binding the fines. And when it binds the fines, it becomes very difficult for the movement of the coal inside the boiler, inside the conveyor or in the pipelines. And then sulfur content. This typically ranges 0.5 to 0.8% in Indian coal. Sometimes in the foreign coal it is 2 to 3%. Recently, I went to Tata Power Trombay. I found them that they are using 0.5% sulfur content Indonesian coal. Is it possible, Indranil?
Yes, sir, absolutely.
Okay.
Indonesian coal is having very low sulfur, whereas Australian coal is having high sulfur.
But what we are receiving at our end, especially in case of Indonesian coal, we are getting on a bit higher end, means we are getting sulfur above 1.5 and above.
Is it RB2 or RB3?
That thing, राघव जी आपको
RB,
कुछ
Prashant ji, RB2 or RB3 is basically South African coal. and
अच्छा
you are
अच्छा
talking about Indonesian coal.
Okay, yeah, exactly. RB Indonesian coal, what I have seen, it is within 0.5, 1% is quite I have
Indonesia,
never seen.
in case of Indonesian coal, you have the range from 0.10, 0.1 to 1.5 level of sulfur.
Okay,
0.5
It
up
okay.
to
depends on the
0.5.
mine to mine and area.
Yeah,
Yes.
yeah. Okay. More to confirm, are you getting it from Mundra port?
Sorry.
Are you getting this coal from Mundra port?
Uh,
Indonesian coal?
depend on the plant where we require the coal.
Okay. Because
Uh,
Mundra port data may be available for me. Those are accessible for me. I can get you those data also. Okay.
which one? Sorry, I didn't get you.
Mundra port, Indonesian coal, whatever Mundra port gets, whatever Adani Power and Tata Power gets at Mundra, that
Uh,
that that coal data is available, is accessible to me. That coal
the
analysis data.
Sir, the coal which you are talking about
Hmm.
regarding the Tata Power or Adani Power,
Hmm.
that is basically Bhumi coal, which
Yes, Bhumi
KPC.
coal. Perfect,
Correct.
perfect, perfect.
KPC is historically a low sulfur coal, high
Uh,
GCV, low sulfur coal, and that was
hmm.
the reason Tata has invested in that particular mine.
Perfect.
In regards to Adani is basically a mix of everything.
Yes,
They have contracts with almost every miner in Indonesia as well as in South Africa.
perfect, perfect. Absolutely. So, anyway, this is uh, a thing which will not get deteriorated, means point 0.8 will not become point 0.5 upon storage. So, we'll talk about it later. Okay. Now, sulfur affects the clinkering and slagging tendencies, especially pyritic sulfur. If it is with iron, if it is FES, it causes slagging tendencies and it corrodes the chimney and other equipments such as air heaters, air preheaters, economizers, and it limits the exit gas temperatures. Okay, exit flue gas temperature necessarily be more than 120. We keep it about 124 to 128. Otherwise, you will face challenges in your ID fans as well as chimney internals. Now, properties of coal. We'll talk about slagging and fouling index also, and there is an Excel sheet for that as well. So, coal properties are evaluated by different methods. There are mostly proximate analysis method, which we know. Proximate analysis gives us moisture, ash, volatile matter, and fixed carbon is 100 minus moisture, ash, and volatile matter. Ultimate analysis gives us elemental composition of coal. Fusion characteristics of coal is the estimate of initial deformation temperature, hemispherical temperature, and fusion temperature of the ash, and which is necessary to be determined for its slagging and fouling index. And ash oxide analysis is commonly used for analysis of ash composition. Calcium in ash or the uh, calcium, magnesium in ash, titanium in ash. These have importance as well as alumina in ash is very important. Alumina in ash will cause more of your erosive behavior on the ash uh, handling unit. Ash analysis is used to characterize the slagging and fouling potential of the coal. We are not yet into the subject of storage. We are just talking about the properties of coal. Okay, we will be inside the cold storage space very soon. Now, these are the things which we need to understand when we talk about you know slagging and fouling index. Here is the propensity of slagging and fouling. Where my cursor is going, I think you will be able to see my cursor. Slagging and fouling propensity: low, medium, high, severe. So, ash fusion temperature Below 1350 is high and severe. Now, base to acid ratio in your ash, the formula is given here: iron, calcium oxide, magnesium oxide, sodium oxide, potassium oxide divided by silica, alumina, and titanium oxide. If it is 0.4 to 0.7, then it is high and severe. If it is below 0.4 or above 0.7, then it is low. Similarly, slagging factor, base upon acid into sulfur in coal. So this into sulfur in coal. That is, if it is less than 0.6, it is low. 0.6 to 0.2, it is medium. 0.2 to 2.6, it is high. Above 2.6 is severe. Similarly, temperature at 250, temperature T250 it is called. T250 is M. M is, the formula is given there, 0.00835 into silica into plus 0.00601 into alumina minus 0.109. These are the few things which you need to put in the Excel sheet, and you will be able to find what is the propensity of your coal. You have AFBC and CFBC boilers only, right, sir?
No, we have only AFBC boilers.
AFBC boilers, okay. And old boilers, quite old boilers?
Not old, hardly. No, on an average, it is 10 years, 10 to 11 years.
Okay. And you don't have this fouling and slagging propensity in the system?
No,
Any?
no.
No, no,
Okay.
no.
Just a moment. My battery is low. I need to start it. Huh? Just hold on.
Sir, are you running the plant with 100% imported coal?
Yes, we are running.
Okay. Sorry for the interruption. Actually, I was running without power to my system. Now resume power. So this could be useful to you in case if you find any problem in the system. You can calculate the things through this chart and use it for your benefit if you are facing any kind of problem in your boiler. Now, fixed carbon, what boiler engineers must always be aware of. Fixed carbon. Now, this is the solid fuel left in the furnace after volatile matter is distilled off. Do you know this? When the VM is distilled off, if it is removed, you get solid fuel left in the furnace. That is the fuel, fixed carbon. And it consists mostly of carbon, but also contains some hydrogen, oxygen, sulfur, and nitrogen, which is not driven off with the gases. That here your secondary air requirement may be because of this. Now, fixed carbon gives a rough estimate of heating value of a coal, whereas the volatile matter, the methane, hydrocarbon, hydrogen, and carbon monoxide, and the incombustible gases like carbon dioxide and nitrogen found in the coal. So the volatile matter is an index of gaseous fuel present, which typically the range we had a talk 20 to 35, proportionately increases the flame length and helps easier ignition. Such limit of the furnace height influences secondary air requirement and secondary oil support. Coal grindability index. Coal grindability index, it affects the mill performance. Uh, Sir, is there any problem anywhere?
No.
Raghu sir, no, no. Actually, I'm getting some I was getting some noise behind.
No, it's not. It's not from my this thing because nobody is there yet.
Okay, sir. So then the ash content, it reduces handling and burning capacity, causes clinkering and slagging. After combustion, affects the combustion efficiency and boiler efficiency. Moisture in coal must be transported, handled, and stored. So, higher the moisture means higher the losses. Not only the loss of transportation, but also loss as it takes away the heat, the latent heat of evaporation from the furnace. So it is hardly transferred into any of the heat exchanger or any of the pipes. The latent heat of evaporation will be away with the vapors which are going away from the boiler. And sulfur content, it as we talked about, limits the exit flue gas temperature. So if you are having 1.2 percentage of sulfur, then you need to be more cautious. Now, what Indian, Indonesian, and South African coal look like to me with the data what I have is mentioned over here. Okay, G3B for Indonesian coal is about 5500, whereas South African coal 6500. Whereas if you see the total moisture, the moisture percentage Indonesian coal should have been between 10 to 30, while South African coal is only 8. In these conditions, South African coal proves to be better in many senses, uh, whereas the ash percentage is slightly higher, but it's still manageable. Volatile matter which makes the most out of it. FC upon VM. Here you see FC upon VM is
Yes.
around 2. Is around
Probably
2.
combustion.
Pavitra ji, just
Yes, sir.
sorry, I'm cutting in short with to you. जो आपने इंडोनेशियन कोल जो आप दिखा रहे हैं, ये कौन सा जीसीबी का है?
5500.
5500 एआरबी और एडीबी?
ये सब
ये
एडीबी
AR
होता है नॉर्मली. नो नो, आई थिंक इट्स
ARB.
एडीबी.
नहीं हो सकता.
नहीं, नहीं.
ये मेरे
ये
मेरे
ARB है. ARB है, सर.
साहब, तो फिर साउथ अफ्रीकन एआरबी 6500 नहीं हो सकता, क्योंकि साउथ
65.
अफ्रीकन ईडीबी 6500 होता है.
मेरा भी वही डाउट था. ठीक.
नहीं सर, 6500
सर
हमको
ये एडीपी में ही
टाटा
है.
पावर में.
नहीं, ये जो नॉर्मली वॉट एवर डाटा वी गेट, बनर्जी साहब, आई जस्ट वांट टू ये वॉट एवर डाटा वी गेट ना, दिस इज एडीबी डाटा, नॉट एआरबी डाटा.
एयर
एंड
ड्राइव
सर, अगर
बेसिस.
इंडोनेशियन का अगर आपका 5500 एडीबी अगर है, तो आपका जो टोटल मॉइस्चर है वो 30% नहीं हो सकता.
नहीं, ये सर ARB में ही है. एक्चुअल में जब मैं टाटा पावर में काम करता था उस समय के डेटा है. ये आज से 12 साल पहले के डेटा है.
साहब देखिए, जो साउथ अफ्रीकन है वो RB1 है, ये जो आप डाटा दिखा रहे हैं.
हम्म.
और
सर मुझे
RB1 जो है वो
RB1 RB2 उस समय हमारे पास ऐसा कुछ आता नहीं था कि क्या RB1
करेक्ट
है, क्या
12
RB2
साल
है.
पहले नहीं आता था. करेक्ट, आप
हाँ,
बिल्कुल सही बात बोल रहे हैं साहब. उस टाइम पे जो आता था वो साउथ अफ्रीकन हमेशा नार में चलता है,
हाँ,
और वो 6300 नार करके बिकता था.
हाँ, हाँ,
6000 नार ब्रदर, 6300 में
हाँ.
6000 नार.
हम्म. तो ये डेटा मेरे को अपने ही लैब से उस टाइम टाटा पावर से ही मिला था, तो उसीलिए ये मैं आपको यहाँ पर दिखा रहा हूँ. खैर, दीज आर नॉट सो इम्पोर्टेंट
चलिए.
बिकॉज अभी
हाँ
जो
नहीं,
आपको
ठीक है,
मिल रहा
ठीक
है.
है, ठीक है.
और एज सॉफ्टनिंग टेम्परेचर जो है वो एक इशू था साउथ अफ्रीकन कोल के साथ. अभी हम रशियन कोल भी यूज करते हैं इंडिया में, और रशियन कोल में हमें एक्चुअल में फाइन्स और स्टिकीनेस ज्यादा मिलता है. लेकिन इसके बारे में एक्चुअल में हमारे इंद्रनील ज्यादा बता पाएंगे, क्योंकि हमारे कंपनी के हमारे ग्रुप के वही कोल एक्सपर्ट हैं। अभी वाई बॉयलर डिजाइन इज अफेक्टेड बाय कोल, एफसी बाय वीएम। अब देखिए एफसी बाय वीएम की बात मैं बार बार इसलिए कर रहा हूँ कि ये स्टोरेज में आपको मैं कुछ ग्राफ्स दिखाऊंगा, कुछ पेपर्स हैं मेरे पास which will show you that FC and VM both reduces with the storage. Okay, so FC by VM ratio is considered for the boiler design. Ash per million kilocals and initial deformation temperature is taken in consideration. Slagging characteristic of ash and ash erosion characteristic. These are taken for boiler design. Now, how boiler is affected by coal quality? Convective section of the boiler consists of large bundle of tubes arranged inside the gas path to extract heat from the flue gas. Ash percentage is to be considered over here. Erosion to the ash is a major consideration in this section. The maximum permissible velocity is proportional to the ash quantity and abrasive nature of the ash. Silica and alumina, which are typically high in Indian coals, they have high abrasive in nature, and we were finding every bends and things in the pneumatic conveying system are getting eroded due to this alumina. So therefore a maximum permissible velocity is limited on those pipes. The metal loss due to erosion is depending on the spatial variation in the velocity. So core parameters critical to maximum permissible velocity is ash content and ash silica, particularly alpha quartz and alumina. Objective of the coal firing system is to enable complete combustion of the coal particles, limit the formation of pollutants like NOx. Coal properties affecting combustion is fuel ratio, fixed carbon divided by volatile matter is commonly used. But nowadays, new, vicinite and other things has also come, reflectance, which also affects the combustion. And more advanced analysis rely on mackerel analysis and vitrinite reflectance. These are two things which are uh, very important for evaluating combustion performance. Commonly,
What are these two analysis? Macrolide analysis and vitrinite reflectance.
These are actually, this depends on the coal age, and this is done in Australia. Indranil, have we started doing these in India somewhere?
No, sir, not yet.
That only.
Okay, this depends on the coal age, and this talks about the when the coal becomes more aged, then a reflectance into it, and mackerel analysis is about mineral matters in it. How much mineral matters and what the mineral matters are going to affect in the combustion performance. Especially it affects the supercritical boilers. Okay, now if you see the particle ignition and combustion characteristic of coal, now for the furnace design, if I am doing it on bituminous, low and medium slagging, it will be of lower height. If I am doing it on subbituminous, high slagging, the height will be slightly higher. And when I'm on lignite, the height of furnace will be large. You can see from this slide that coal properties define the furnace height and its limitations. It's dia as well. And you see the initial shoot blowers, where are they put and where the future shoot blower would be required. Correct.
Okay.
So this volumetric height release, this release rate is the heat liberated per unit volume in the furnace zone. Maximum value depends on the fuel and ash characteristic. However, for large unit, this may not be the limiting criteria. This is volumetric heat release rate. Then furnace residence time, which may be important for you as well in ABC boiler. A minimum furnace residence time is necessary to ensure complete combustion of fuel. So please check that, because if uh, your unburned carbon is high, you may not be having that minimum furnace residence time which is required. Furnace residence time is calculated from the top burner to furnace exit, inlet of latent heat exchanger. From the top burner to the furnace exit. The choice of furnace residence time depends on the fuel ignition characteristic and reactivity. This reactivity is also not checked in India. It is also checked outside India. But FC upon VM ratio is yes, which could be good indicator of this. Fuel ratio gives a good indication of fuel reactivity. Losses from the boiler that you all know, dry gas losses depends on exit gas temperature and excess air. If you have higher excess air, if you have higher exit flue gas temperature, your losses are going to increase. Loss due to moisture and hydrogen in the fuel. Yes, moisture, every 1% increase in the moisture decrease the boiler efficiency by 0.1 to 0.2%. Hydrogen coal, every 1% increase in hydrogen content decreases the boiler
This every 1% increase in moisture, what is the reference moisture we are taking? Because all coal will have certain amount of moisture. What is the reference moisture we are taking? Is it
whatever
it has
you
been
are
designed
getting
for?
right now, what has been designed for in the boiler, from that,
Uh-huh.
if you are increasing 1%, then your
Acha.
boiler efficiency will go down. It is
Okay.
No, no, no.
this all.
Samitaji. Mr. Banerjee.
Sir, fully.
From the design also, if we go 1% higher, then maybe it will increase the or reduce the efficiency. Same way, even if it is, if we compare it from the less than the design, then also it will have the same impact now. So moisture
No,
from anywhere, any baseline
no,
you
no.
take.
Actually, see, either you take it from your baseline data, or you take it from the design data. Whatever you will take, it will always decrease the boiler efficiency. Increase in moisture will decrease the boiler efficiency. Okay, if it is,
Yes.
say if now, why we are talking about design, because you have design versus design efficiency, right? And you do boiler efficiency calculation and compare it to the design. That is why we are talking about the design. Otherwise, you can take the baseline data also. There is no issue about it, sir.
Yes.
Okay. Actually, everything takes a baseline data, which is known as footprint data. Say suppose first
Yeah.
3 years, 4 years, whatever you have run, whatever coal you have run, that becomes a footprint for you. And from there, you and your management compares your efficiency, coal combustion, coal consumption as well from that. Now, hydrogen. In the case of hydrogen, similarly as moisture, every 1% increase will decrease the boiler efficiency by 1.2 to 2%. And it is just because of the latent heat of evaporation which is taken up by the H2O formed after the combustion. But in fact, if you see the complete picture, more hydrogen gives you more kilocalorific value instead of the boiler efficiency going down. Sensible heat.
No, what is true then? Because there are two contradictory phenomena taking place. One is that hydrogen combining with oxygen forms moisture, and then it takes away your efficiency. It's
It
away
takes
your efficiency.
it.
Another is that hydrogen, when combined with oxygen, it is generating a lot of heat. 527, I think I remember 572 or 572. Yes,
572.
megajoule. Yes. So what is the net impact?
So the net impact is actually increase in uh, the heat liberation. Increase in heat
That is
liberation.
so that is good.
See boiler efficiency, sir. What we do is we calculate the boiler efficiency by the enthalpy generated in the superheated steam divided by kilocalories divided by the kilocalorie of fuel burnt, right, into
Yes.
kg of
Yes.
fuel.
Yes.
Now,
Yes.
boiler efficiency means, when we mean that, it means that our efficiency may have come down as compared to the kilocalories being generated, being given. But in fact, the kilocalories due to hydrogen are so high that the latent heat of evaporation does not really supersede that. If you can
Yeah. So
understand, if you can understand
on.
me, if it is
Yeah.
527 megajoules it is producing, but as the H2O which it is producing, if you just take H2O into the enthalpy of at that temperature, the of saturated steam, okay, that is saturated steam only. If you multiply by the saturated steam, you'll find that the heat generated due to hydrogen is higher still than the loss due to the latent heat of evaporation which is it has carried.
Yes.
Okay, so it's always you will see, uh, uh, when I supply you this Excel sheet, you can do the calculation yourself also. Uh, the enthalpy of this thing, about the saturated steam, it would be at 120 degrees, right? You may be having a steam tab, or you can ask me. I can get you the data, and that enthalpy multiplied by the volume of water vapor formed, uh, is the heat carried away would be lesser than the heat generated by the hydrogen. But still, due to that, H2O which has formed, whatever efficiency you could have got will be lesser due to that H2O formation. If say that H2O formation may not have taken place, then your efficiency would have been higher by 1.5 to 2%. That is what I mean here.
No, no. What really we are bothered about is that H2 plus O2 is equal to H2O plus 527 kilocalories. And
Yes,
now this
enough
H2O,
megajoules.
now this H2O would require some heat, some enthalpy rather. So out of 525, let us say it will take away some, let
Let
225.
us
So still you have 300 plus.
let us do, yes. Still you have much more.
Because the latent heat of enthalpy of जो evaporated steam है उसका ज्यादा आ जाता है. I think it is 730 or something. The latent heat of
नहीं, नहीं,
vaporization.
सर
no, no, no.
यहाँ देखिए, यदि आप 4 हाइड्रोजन है अपने पास या 3 हाइड्रोजन है,
Yes.
कितना आपके पास कितना हाइड्रोजन होगा फ्यूल में? somebody may be
Hydrogen
aware.
इतना ही आता है.
2%.
Let us see.
It is around 3%.
3%. Okay, which combines with this much of CO2 and gives 0.27 kg of H2O. It has given 941.2 kilocalories already. Now 0.27 kg of H2O, if you calculate by steam tab, 0.27 kg of H2O will carry how much of enthalpy? Saturated? What
Yes.
temperature
It's
is your
latent heat.
it will give you
Latent heat of vaporization, I think it's 830 something.
Sir, latent heat of evaporation is
No, no.
560.
He's saying only
560
0.27
kilojoules.
kg.
No, latent heat of evaporation is 560 kilojoules.
Okay.
Okay. Now we calculate
At
from the saturated stream. Now we'll get the enthalpy here. Now what is the temperature you are maintaining at your exit flue gas?
And take it up 125.
Okay. And it's two phase.
two phase means
Vapor, sorry.
it's vapor only.
So enthalpy is 2713.1 kilojoules per kg. Now I say 2713
Into 0.27.
2713.27. This is kilojoules, huh?
Yes.
2.27.
Yes. Yes. Yes.
Okay. Now you need to convert into
Kilocalories.
732 kilojoules. It is coming. 733, you say?
Divided by 4 point what? Or you can directly see from there. Yes.
Energy, na?
Kilojoule to kilocalories.
Energy power converter.
Yes. Yes. Above this. Yes.
Kilojoules.
It may be giving joules only. Yeah. Kilojoule is also there.
Yes, kilojoule is also there. And I'll
Yes.
put here 732.59 and I'll get it into kilocalories. This is kilocalorie.
Yes.
174. So that is what I was saying. 941.2 is much higher than 174.97. So ultimately, the energy which you are getting is higher if hydrogen is higher. That is what I meant. Have you understood, sir? Jena, sir?
Yes. Yes.
Yes. Yes.
The energy which you are.
But you said this volatile matter because hydrogen is counted in volatile matter, na?
Yes, part of it, sir. Not
It's
completely.
yes.
Part
So
of
if
it.
it is stored for a longer period, so maybe we
Then
will be
you will
losing that.
lose. You will lose it. You will lose that hydrogen.
Yeah.
I'll come to those graphs as well.
You'll be losing all the components. Volatile matter will get reduced with the storage time
And your,
increase.
and your combustion will be very difficult if you're increasing more than 21 days. It is very difficult, right, Indranil?
Right, sir. After 21, 22 days, it is getting degraded.
So may I close these, sir?
Yeah. Yeah.
Okay, thank you. I'll close this and I'll see. I think Steam tab and these tools are there with you. The only thing I have to give you this Excel sheet, right?
Yeah.
Yes.
Yes.
And this Excel sheet also, if you'll see, it has considered megajoules to kilocalories already. Yeah. Okay.
Yes. So how often do we require to do this ultimate analysis of coal and check our efficiencies?
Sir,
Because
if you
this
have
direct efficiency is nowhere near to that indirect efficiency.
yes, very true, sir. Absolutely, you're making very big sense, which is very important for all of us. That we have seen this direct efficiency is no way nearer to the indirect efficiency. Actually, ultimate analysis, if you have a particular coal source, like in India, when say, well, I worked with many of the companies, including from in Tata Power, we had fixed two sources. One was MCL and another was West Bokaro. So that was very easy for us to understand and do these things once in a month. But when I changed to Adani, I had multiple sources. Okay, but still Indonesian was highest, and of South African was little lower. At that time, I was getting South African as well. I'm the first chemist who has commissioned supercritical stations in India, means chemistry commissioning, because supercritical chemistry is very important. So I found it a bit difficult. Then we started getting this ultimate analysis done in our lab. We developed a big lab, core lab, and this ultimate analysis was done for every vessel there. So such kind of big companies, which is having 4,620 megawatt at one place, can afford that. But smaller plants cannot afford that. If you have a single source of coal, then you may still go for once in a month. Otherwise, you may go for once in a once in 15 days, fortnight or so, so that you can check, you can compare when that coal, if you're doing it on FIFO basis, you know when you are burning that coal and when you are getting that sample analyzed outside.
No, FIFO is used in our Indian context or what? Because
Yes,
because it is it is practically not it does not it is not practical basically, I would say,
it is
because
whenever.
the kind of storage area we have, what happens is that the older coal goes backside and then newer coal comes this side, so
I
we
I I,
cannot pick
I beg to
the
I beg
backside
to
of the coal.
I beg to differ with you, sir. Even I'm a consultant for Dalmia Cement, Ultratech Cement, and they are also having smaller units. And also for Dalmia, not only for Dalmia, also for the CK Birla Group companies. So they still follow FIFO. Okay,
राघव
they
जी, फीफो फॉलो करना ही पड़ेगा, जैसा बैनर्जी साहब भी बोल रहे हो। वो क्या होता है, आप जितना दिन, जैसा आप बता रहे हैं, आपका ठीक है, वो प्रॉब्लम है, पीछे कोयला रह जाता है, मगर वो क्या होता है ना, जैसा आप कोल रखते हो, वो एक्चुअली आप पैसा एक तरह से जला रहे हो। क्यों बोलते हो, एक तो उसका जीसीबी डाउन हो जा रहा है,
sir,
एफसी लॉस
sir,
हो रहा
this
है,
this
हाइड्रो
this
वोलेटाइल
this
मैटर डाउन
this
हो रहा है,
this
वो
नहीं नहीं
हमारे
नहीं
लिए लॉस ही हो जाता है।
man,
नहीं नहीं
this you can discuss internally, sir. But what I'm saying here is that FIFO is very important, which I will show you in next of my slides. Why FIFO is important? Why we can't keep the coal for a longer duration under storage? That we will discuss. Okay. Ultimately, if you are not following FIFO, you are losing rupees. Okay. You can discuss this
Yes.
internally later. Anyway, because let us not go into the debate right now. Let us learn what is there with us. Okay, and let me also learn from you. Now, sensible heat due to ash. So every 1% increase in ash content decreases the boiler efficiency by 0.02% approximately. ESP, sizing of ESP will depend on the ash content that you all know. Moisture and hydrogen in coal plays a very important role in sizing the ESP. And now if you have deviated from it, your ESP may not be performing to the requirement. Moisture in flue gas decreases the dust resistivity, thereby improving the collection. And as constituents like sodium, sulfur in coal reduces the resistivity of ash, thereby again it gets attached to the uh, corona and get, get discharged. Now, Indian coals are generally low in sulfur. However, owing to the low GCV, the sulfur dioxide emission from Indian power station is 700 to 1000 milligrams per normal meter cube, which is well above the prevalent norms in Europe, Japan, and USA. And now, Indian government is trying to reduce this as well. They have made plans to get this mandatorily done with them. Now, FGD is required in many cases where the sulfur in the coal is even 0.5%, like in Tata Power Trombay. Even a small plant, RSPL, Ghadi detergent plant at Porbandar. I'm a consultant for that plant also. They have also asked to get FGD installed. Now, influence on coal mill, mainly HGI. HGI is hard groove index. Higher is the hard groove index, softer is the coal. Okay, it's just opposite. Lower is the hard groove index, harder is the coal. So it affects mill outlet temperature, mill motor amperes, mill airflow, wear part life. The parts will wear faster. The mill pressure drop will be higher. Mill output will be lower. Mill fineness fractions will be difficult to ascertain properly. If the HGI is low, then you will get the lower fineness, in fact, and mill reject rate will be higher if it is lower HGI. These are the hard groove index machines used at that time. Uh, are you concerned with hard groove index anyway? Jubilant?
No.
No, we are not checking.
Okay. So I had videos to show you anyway.
It
Now
is required
determine.
for pulverized coal. I think it is required.
Yes, pulverized coal.
Uh,
It is must for
we are not
pulverized
using
fuel.
that.
Yeah, yes.
नहीं, एचजीआई का ऊपर ही हम लोग का सीएचपी का सिस्टम जो डिजाइन होता है, जो प्राइमरी क्रशर सेकेंडरी क्रशर वो जो है ना, दैट डिपेंड्स अपॉन द एचजीआई.
HGI पे डिपेंड करता है वो.
Yes.
प्राइमरी क्रशर सेकेंडरी क्रशर HGI पे डिपेंड करता है.
Yes.
तो ये HGI मशीन्स हैं. अभी जो आ रहे हैं HGI मशीन्स बहुत इजी और अच्छे हैं. हम जो यूज करते थे पहले उससे ये डिफरेंट है सर.
अच्छा अच्छा.
ये चाइनीज में लिखा है, इंग्लिश वर्जन भी अवेलेबल है. तो थोड़ा प्रिसीजन एनालिसिस है ये.
ग्राइंडिंग कर रहे हैं क्या ये?
हाँ, ग्राइंडिंग.
The balls are grinding media ना.
ग्राइंडिंग करके इसको इस सीव से पास करेंगे. सीव से पास करेंगे और जितना पास हुआ है उसके अनुसार ही इसको. ठीक है, इसको बंद करता हूं अभी.
Yes. Yes.
ये हार्ड ग्रुप इंडेक्स का तरीका है मेजर करने का. ASTM स्टैंडर्ड D409 पे है. नाउ लैक ऑफ कैपेसिटी ऑफ हाई पावर कंजम्पशन मिल्स में, मिल्स तो आपके पास है नहीं, तो ये हाई मॉइस्चर, इंक्रीज रॉ कोल साइज, एक्सेसिव बेड डेप्थ, इंस्ट्रूमेंट एरर, ग्राइंडिंग टू फाइन, लो जीसीबी, सब उसकी प्रॉब्लम रहती है। मिल रिजेक्ट्स एक्सेसिव होते हैं, मिल फायर्स। ईएसपी तो आपके पास होंगे ही जरूर, तो
Yes.
तो इसके लिए कोल ऐश ड्यू टू इंक्रीज इन द इनलेट डस्ट बर्डन, ऐश ज्यादा होगा तो उसकी एफिशिएंसी कम होगी। precipitability of ash improves with increase in flue gas moisture content. Sulfur content increase होगा तो the precipitability will increase. Precipitate uh, precipitability of fly ash improves with the increase in fly ash base by acid ratio or sodium oxide and lithium oxide in the ash, and its efficiency, precipitator efficiency increases with increase in the fly ash particle size, which is affected by pulverized fuel size. So you don't have pulverized fuel, so coarse PF tends to yield a large average fly ash particle size. This coal property effects on particulate dust burden. 1% increase in dust burden will increase the emission by 1%. Gas flow, 1% increase in gas flow per unit heat release will increase emission by 1.5%. As resistivity, a resistivity change of one order of magnitude would suggest increase in emission by factor of 2. Sulfur, general trend of reducing resistivity as sulfur increases, possibly one order of magnitude 1% sulfur change. Below 1% sulfur resistivity is dominated by other factors. तो ये एफिशिएंसी उसके बारे में है, ईएसपी के बारे में है। नाउ लेट्स समराइज दिस। जो हमने नॉर्मल प्रैक्टिस किया है सरफेस सैम्पलिंग, लेकिन मतलब एज पर स्टैंडर्ड हमें डेप्थ में सैम्पलिंग करना पड़ रहा है, पढ़ना होना चाहिए। नाउ Indranil will talk about these things after my next slides. Okay, after I take over talk about the storage, Indranil will talk about these normal practice and as per standard what are the things which we are missing. नॉर्मल प्रैक्टिस में हम सरफेस से सैम्पलिंग कर लेते हैं, लेकिन एज पर स्टैंडर्ड हमें डेप्थ से सैम्पलिंग करना चाहिए। इवन स्मॉलर प्लांट्स like Hindustan Zinc, which are having smaller CPPs, they are basically doing it by auger. Single lot is prepared for the whole rake, is the normal practice, while 6 sublots needs to be produced. Not able to collect big size, which is not coming in the scoop. For big chunk, actually, as per standard, proportionate quantity needs to be broken and considered as sample. Stripping down the raw sample in terms of quantity, gross sample actually as per standard, gross sample needs to be crushed to bring homogeneity first. Again, a normal practice sometimes consider 95% passing of powder sample through 72 mesh at laboratory sample, whereas actually 100% powder sample needs to be passed through 72 mesh. And then about total moisture analysis, we follow standard time for total moisture analysis, whereas we need constant weight which needs to be achieved. In General Stainless Limited, we had similar problem that they are not going down to the constant weight method. We went into the constant weight method and they achieved their boiler efficiency particularly and their heat rates as well. And sometimes small trays are used, resulting abnormal results in air drying. Standard size tray needs to be used. And as a normal practice, only benzoic acid is used for bomb calorimeter calibration. We need to use CRM, and Indranil will talk about the CRM more. Now, I'll go to my next slide. This thing. Next one is about cold storage, which is the most important topic for today. Till now, we talked about this FC, GM, VM, FC, VM, carbon, GCV, ash. Now, what do you think this slide is showing you? This is for the period of November to September. December, Jan, Feb, March, April, nearly a year.
The
In
ash
1
content
year,
is increasing continuously, no?
sir, ash percentage is increasing continuously because you're losing carbon, volatile matter,
Yes,
and
everything is.
yeah. So what is happening when you are keeping this thing with you, the coal for a longer period? You are continuously say you have kept 1 kg of coal, right? That 1 kg of coal will ultimately become zero point 0.7 kg of coal, but in that zero point 0.7 kg of sulfur and ash will remain, uh, uh, like earlier it was 0.25 kg and 0.2 kg. So it
Yeah,
will,
yeah.
sorry, 0.02 kg, that will remain same. So now proportionately percentage of ash and percentage of sulfur will actually increase. So this is over a period of 1 year. Now, even if you consider November to Jan, 3 months period, you see a considerable drop from 100% to 85%, and you lose a lot here. 15% loss in GCV is significant. 50% loss in even fixed carbon volatile matter, because GCV is considering all that, right? Fixed carbon volatile matter. So you are actually losing money when you are not following FIFO. If you're keeping the coal for a longer duration in the storage, and that also in an open storage, now there are closed covered storages are available. But anyway, in the covered storage also, VM will go up and will be uh, in the top of the cover, and as soon as you remove the coal, you lose still the VM and the carbon associated with the VM. So this is the first slide which I'm showing you, and this is the gist of the whole presentation on storage. This is this slides are will be called effect of weathering on physiochemical properties and combustion behavior or thermal coal. Now, if you see, if I try to tell you straight away that a stockpile which I have used means, there is a paper which has been written by me, okay, which I used, found with 3.5 meter base diameter and 5 meter height, using 500 tons of 200 size ROM coal. So the coal sample from stockpile was collected at every 30 days interval for analysis for various chemical properties like proximate analysis, ultimate analysis, GCV, and various combustible combustion related properties, which I'll show you in the next slide. Okay, such as ignition temperature, peak temperature, burnout temperature, maximum combustion rate. These are very important characteristics which normally people do not check. Ignition temperature, people do not check. Peak temperature, people do not check. Burnout temperature, people may not be knowing about this. Maximum combustion rate, that also may not be knowing. And there is an ignition index. So I'll tell you in the later slides, and if required, I'll get you a paper also on this. So experimental results which we did has shown that fixed carbon decreased from 35.6% to 19.9%. Elemental carbon, fixed carbon is different, which is remaining after VM has gone, but elemental carbon means which was there with the VM also, that has decreased from 46.6 to 28.6. Hydrogen decreased from 3.3 to 2.9. Then GCV decreased by 55% during 330 days of storage. That is significant, significant. And if you see the latest slide, this is almost linear. Drop in GCV is almost linear. Even if I make a trend line out of it, it will be linear only. Then the ash content of the coal, because you have lost carbon and hydrogen or volatile matter, the ash content increased from 29.2% to 46.6%. And sulfur as well has increased because these two as had been constant, right? In 1 kg it was 29.2 0.29 kg. In 1 kg it was 0.29 kg. And as soon as I lost the weight of the coal, if the coal has become 0.7 kg, that 0.29 kg has become higher percentage to 46.6%. Similarly, sulfur of the coal, that has also increased, and that will increase your sulfur dioxide emission as well. The activation energy which is required for coal combustion, that increased from 22 kilojoules per mole to 54 kilojoules per mole, means the activation energy which is required to start the combustion of that fuel has increased. So you have lost lot of things during the storage. The general practice is to provide up to 2 weeks stockpile in case of a pithead utility, 30 to 45 days capacity, or 50,000 to 800,000 tons of coal for large power plants, because they need every day 20,000 tons of coal. So for them, yeah, for them it is quite a 7,000 is what is the requirement. They are keeping 12 days of coal. That is fine. So two weeks stockpile is good enough. And if I purchase a coal at a lower price, maybe a 10% or 15% lower price, and keep it uh, for a duration of 1 month, I will lose that 15% profit what I should be getting out of it. And coast-based utilities burning imported coal have a tendency of buying large volume of coal from overseas market. But stockpile coal for a long time causes the coal getting exposed to various oxidative conditions, which is known as weathering of coal. So if you click in the Google weathering of coal, you'll find a lot of literatures available about this. The exposure of coal to the condition lead to the oxidation of coal that might result in deterioration of coal GCV. So GCV has dropped. You have seen in that graph, and some more graph I'm going to show you next few slides. In modified coal behavior during grinding and combustion, finally in the large amount of ash generation. So finally the ash is also higher due to the exposure of coal, weathering of coal, which has lost its GCV, carbon and other things. So weathering of coal is a matter of great importance for any power plant. Scientists have studied the surface properties of anthracite coal before and after the weathering process. They observed that carbon hydrogen groups on the surface of anthracite coal was decreased after weathering process, while the carbon oxygen or carbon double bond oxygen and CO2 groups were increased. So weathering of coal means oxidation of coal has happened. Few more scientists they were from China, in fact, few more scientists, the other people, they studied the combustion behavior of weathered coal and reported that combustion performance varied between sample taken from within the sample stockpile at different depths. So on the top it was different, 0.5 meters it was different, 1.5 meters it was different, and also between samples from different particle size. So as small the particle size, higher is the weathering. If you can understand, smaller smaller coal will have higher weathering. smaller particle size will have higher oxidation. Chemical and petrographic compositions were checked between weathered state and original coal. Therefore, it was stated that weathering of coal largely affects the coal properties by changing the surface properties, chemical bonding between carbon, hydrogen, oxygen, and other elements present in the coal. And the only major published work on Indian coal, me et al., reported coal quality deterioration in coal stockpile of a utility. And within a month, we have got 7% deterioration in the quality of the coal. In our studies, we showed that significant amount of GCV was lost, and CAG was also involved with us for this study. We also reported that due to weathering, coal loses its cohesion and disintegrates into progressive smaller pieces which may be washed away. Now, this is what we did actually. We did weight loss analysis, which was termed as TGA, rate of weight loss, the rate at which the weight loss was happening, which was denoted by DGT, uh, DTG data points, and the different combustion properties. One is temperature of ignition, at which the coal should ignite. The peak temperature, the highest temperature the coal can come, and the temperature of burnout. Before charring, there is a burnout. The temperature of the burnout were identified. So TI means temperature of ignition is defined the temperature at which fuel shows weight loss of 1% per minute and signifies the initiation of combustion process. Peak temperature TP is the temperature corresponds to maximum weight loss rate, and the burnout temperature corresponds to the completion of combustion before the charring, when the rate of weight loss reduces to 1% per minute. Further from that weight loss and rate of weight loss data, different combustion indices like index of ignition, index of burnout, index of combustion that we have got, and we calculated the manner. I've kept the formula here, and later if you need some more data on this, I can supply you some more data on this. And then this is what we found actually. You see the rate of weight loss, DGT max, 8% minimum from November 2015 to October 2016. It was very linear, but quite fast. Then temperature of ignition, earlier it was 296, now you require 331, means you need more coal to burn more coal. And then peak temperatures, they were going up, and TF temperature of burnout, they were also going high. So ultimately, weathering of coal has affected the combustion rates of the coal. And this is the index of combustion performance. It's called index of combustion performance. For first 3 months, we saw that combustion performance improved, November, December, Jan on weathering. But later on, there was a steep drop from Jan to Feb, and then this was a study, so you cannot be able to conclude out of this. But in later slide, here you can conclude that carbon percentage, which we measured every month, dropped. We measured morning, evening, and we averaged it out. So you see that the first month was critical, as Indranil has told, that 21st day, after 21 days, you will see the deterioration quite fast, and you see the steepness after December. November we kept, and December started deteriorating. The steepness was quite high. So you lost so much of carbon. Now, may I know how much Jubilant is keeping coal for how many months with them at different power
No,
stations?
Around 5 to 6 months.
So from this 1, 2, 3, 4, 5, 6. So you have lost say carbon percentage from 54 to 40. So 14% carbon already you've lost, right? So if you calculate in GCV, I think that will come around 1200 kilocalories or lesser, maybe. But you have lost a significant amount of carbon. Second is hydrogen. You lost hydrogen as well. Hydrogen is significant. As I've shown you that 900 kilocalories was what I was getting minus 147, which I removed through the latent heat of evaporation. Still, my loss of hydrogen will give me a loss in GCV. So my hydrogen percentage has also it has gone down, and the first month itself hydrogen has started deteriorating because hydrogen here was in form of VM, and VM starts getting out within first 7 days itself. So this is how you're getting down. Then from 4% to 3%, 1% loss of hydrogen you had. So 1% of 1 kg is 10 grams. 10 grams hydrogen, if you'll run in the Excel sheet, you'll find a big kilocalories which you have lost. This is the sulfur percentage because in one hand you have seen uh, the loss of carbon and hydrogen and VM, but ash will not go out anywhere. Ash will remain there, and sulfur will also remain there. So relative ash percentage and relative sulfur percentage will go on increasing. So ultimately, you are burning same amount of coal kg in quantities, but making your boiler and auxiliary consumption higher. Your auxiliary consumption would be higher when it is handling more ash. When it is handling more sulfur, you have to keep the temperatures bit higher. Though you'll get a little bit of energy out of sulfur, but that energy remains constant even when it was the first day or it was this 188 180th day. Overall, from the previous slide, you can observe that the variation in carbon, hydrogen, nitrogen, sulfur are not uniform in some cases. Values are lower in previous months and higher in later months. Similarly, morning, evening samples also have significant deviations that can be explained by the fact that coal is extremely heterogeneous. Such weathering occurs due to various physiochemical reactions at in situ of coal surface, which is governed by many parameters like hydrocarbon structure of coal, which is an unknown fact, not 100% known to the people, but also the mineral matter composition, moisture, coal porosity. Coal has a chemi-adsorption property. Coal has a adsorption property. On its surface, it has got many pores on it. So coal porosity is important. Rainfall, fog, the humidity at that place, etc. And the rate of oxidation of core is not uniform for each coal particles. Even the particle size also matters. If the particle size is lower, the rate of oxidation of the coal will be higher. Also higher the temperature, greater the rate of oxidation and heat buildup. Whether fire occurs or not in the heap, the temperature increases and progressively the reaction with atmospheric oxygen will happen and gradually it will impair the coal properties. Coal oxidation, which leads to chemi absorption of oxygen. See, even in the voids, if you have kept the coal at a very high pressure, this thing, and kept in a heap, which I'm going to show you how the heaps are formed. That that still absorbs the oxygen from the voids, whatever oxygen is available, and it's started formation of acid functional groups such as hydroxyl, carboxyl, and other, that leads to subsequent thermal decomposition of that coal and decrease in aliphatic and alicyclic carbon and hydrogen content. Means your hydrogen content is also going down and PM is also going down. Hence, they may result significantly, but the truth remains like this. This is the truth, and I'll show you by GCV also. This is the fixed carbon, variation in the fixed carbon for the year, how steep it was, and then in the month of May, reduced a little bit because of different temperature aspects, and then again it went down. And you see, this is as percentage which let on increasing. The moisture percentage which varied with the moisture in the environment, and now the effect of weathering on GCV. We already saw that carbon and hydrogen concentration or carbon hydrogen content in the stockpile got reduced significantly, contributing to its heat value, and this was declining throughout the period, which we saw in the graphs. And uh, on wetting of coal, because of stockpile heat released on wetting of coal, and which are exposed to alternate rain plus humid weather and then sunshine plus dry climate. So this keeps on differing and keeps on increasing. In addition, rise in sulfur content will always happen as the carbon and hydrogen percentage will go out, and both appear to have contributed to the decay or disintegrated the coal matter through incomplete or sometimes complete combustion if spontaneous combustion is taking place, though no fire has been reported from the coal stockpile. As a result, GCV of the relative low rank coal in the stockpile decreased on month basis from 4,578 kilocal to 2,751 kilocal, a drop of 1827 kilocal per kg, equivalent to 6 commercial grades in virgin India. So seasonal decline in GCV in coal and open air is observed for the whole 1 year. The GCV declined trend observed, and we have noted it down, and it was accepted by Coal India Limited as well. They said the study reported a GCV drop of about 600 kilocal kg in just 5 months. In just 5 months, you are keeping it for 6 months. This is the FC plus VM loss. You can see FC plus VM as black color arrow, and blue color dots are FC upon VM. So FC upon VM is going down. Less than 1.5 is difficult to burn. Then we see the GCV variation.
Manaji sir, wait a
Almo-
minute. Yeah,
huh.
FC upon VM going down is better at one time you said this. Na? So it is
Sorry.
1 point. So just previous graph you could there.
Yeah, na?
Here it is drop. Here it is dropping. So initially it was 1.6 or so. Then it has come down to 0.6.
हाँ, तो हम FC अपन VM के इसमें आते हैं. Less than 1.5 is easier to burn.
Yeah.
Yes. So from here it has dropped, but your FC plus VM is also dropping.
Yeah.
Ultimately, your GCV is dropping, right?
Yeah. Yeah. Definitely.
Yeah, and then you see the GCV drop rate. If you consider from 4,500, 4,600, within 6 months, it has almost dropped to 1,000, dropped by 1,000.
Yeah.
So 1,000 GCV in terms of rupees, you can calculate because you are purchasing the coal as rupees per kilocal. So you can understand how much loss you are making because of the longer storage time.
In the first month itself, November to December, it has
Yeah,
dropped around 3%, 3% or so.
more than that, sir.
Yeah.
More than
From
that, actually,
4,005.
VM get lost, though FC does not get lost quickly. Fixed carbon does not get lost quickly, but the carbon percentage here you see carbon percentage has not lost quickly, but
Yeah.
VM has got lost fast. So
Yes.
that is why the GCV has come down very fast because it that VM contained hydrogen.
Yes.
These are the activation energies, and these are for study
Iron.
purpose only. Okay, this is what we made. Just a moment. So this is what we actually made at that time. From where to where, what to what we have seen, all that we have noted it down. And now regarding spontaneous combustion. So do you need that I should cover spontaneous combustion, or you already know about spontaneous combustion?
No, it's important. Let us go through it now.
Very
This is
good.
one slide only.
No, no, two, 3 slides only. Okay,
Okay. Not on. Not,
not an issue. Thank you. So this is self-heating of coal to its ignition temperature. Actually, more oxygen available to it actually increases the spontaneous combustion. Virtually all grades of coal, except high grade of anthracite, are vulnerable to spontaneous heating and ignition. Although the precise cause is not well defined, even when you keep the coal at a very high pressure, stronger heat, and maybe the heat density is also high, then also you may find some combustion which normally occurs from the sides where the voids are available. It is believed that the coal is, when freshly mined, the fresh surface of the coal, the surface of the coal, when it is mined, the fresh surface of the coal piece liberates the absorbed hydrocarbon. It always contains some amount of methane in the coal bed. So that hydrocarbon gets liberated, which is methane. And then oxygen goes inside those pores. The exposed surface of the coal particles gets oxidized by oxygen in the ambient air. The oxidation, after the oxygen is getting inside, the oxidation is very slow and the heat generation is still there, but it's not understandable very quickly. But if the heat is not allowed to dissipate, the temperature of coal will rise and gradually, but sufficiently enough to cause the whole mass to ignite. It is believed that the self-heating of
sorry.
it
Sorry.
is believed that the self-heating of the coal usually occurs in about 90 to 120 days after the coal is extracted in mining operation. After 90 to 120 days, it starts self-heating. Oxidation in coal stacks takes place mainly from loosely packed coal stack. So we always talk about, when you stack the coal, pack it very compact, make it very compact. And if it is loosely packed, the availability of oxygen in the voids of the stacks are higher. Thus, the rate of oxidation will be higher. The rate of oxidation will be higher at outer surface of the stacks because of the availability of abundant oxygen there, and the rise in temperature still cannot be detected due to dissipation of heat by the air outside. So you will not understand the temperature unless until it starts burning or some smoke is coming out. The zone extends roughly about the depth of 0.5 meters in the stack from the sides specifically. And the situation beyond this zone, say at a depth of 1.5 meter, the situation is different. In that situation, the coal in the zone also oxidizes fairly rapidly in presence of adequate quantity of air entering the stack. But the heat generated in the course of reaction is generally partially dissipated through convection and conduction. There, the heat transfer from this inside zone depends on factor like ambient temperature, rate of air movement around that zone, free moisture available in the material, and the thermal conductivity. The residual heat thus present in the zone further raises the temperature of the coal. The residual heat which is present will further raise the temperature of the coal mass until it attains the critical temperature, that is auto ignition temperature. Once it reaches the critical temperature, the coal in the zone starts burning and smoking and eventually erupts a flame, which we see in many places. And proneness to spontaneous combustion therefore can be determined by ascertaining the critical oxidation temperature or crossing point. All types of coal when हाँ, बोलिए
Okay, continue, please continue.
नहीं कुछ बोल रहे थे
Please cut. Cut. नहीं, मैं कह रहा था वो how do we ascertain that oxidation critical oxidation temperature
वो सैंपल बाहर
is
भेज के
is- हाँ अच्छा
सैंपल सैंपल हमको दे दीजिए हम एनालिसिस करके आपको देते हैं
okay
All types of coal when exposed to the atmosphere are liable to suffer deterioration of quality through surface oxidation. Lignite is a type of brown coal containing high percentage of volatiles, and lignite is subjected to weathering much more rapidly than bituminous coal. So it contains we get a lot of lignite. In India also we have a lot of lignite peated plants. They also face this issue a lot. It contains a large percentage of moisture, has mined maybe 40%, of which nearly 20% exist even before it is mined. Under dry, hot ambient conditions, these lignite, particularly in India, where the temperature in a shed also can go up to 45 degree centigrade and humidity to less than 30%, will lead to ignition. And this lignite will oxidize, and this rate could be quite high. The rate of release of carbon monoxide, which is indicative of oxidation rate, may be as high as 70 meter cube of carbon dioxide per ton of lignite. So carbon monoxide, there are some small equipments available which you can take to the sites differently and you can understand where is the carbon monoxide percentage is high. A very small equipment which is used in steel plants specifically. Okay, because carbon monoxide is quite harmful to human health also. So they always keep and it beeps whenever some ppm level comes into the scenario. So that can also be used, which is about 100 times the normal bituminous coal. So lignite will ignite faster and quickly. And it has been observed that large coal storage yard left undisturbed for long period. Smoldering takes place at the surface layer of the pile. So if you have kept coal for longer time and you're left undisturbed for longer period, you will find that some smoldering is happening. Just one moment. Huh? Yeah. So in case of lignite, the phenomena is very rapid,
What is
highly
this
volatile.
moldering?
Smoldering is like when we do this what do you call welding, na? At that time
Hmm.
you see that kind of spark. मतलब,
Hmm.
it is like uh, जैसे चूल्हे चूल्हे में कोयला जैसे जलता है ना,
अच्छा
चूल्हे
अच्छा।
के अंदर
हम्म।
तंदूर के अंदर या चूल्हे के अंदर जैसा कोयला जलता है, that kind of thing is smoldering. So we will see reddish color over there. Then highly volatile coal is particularly liable to spontaneous combustion. Safeguard guidelines for spontaneous combustion. The ground or floor where the coal is to be stored should be thoroughly cleaned of leaves, grass, weeds, pieces of woods, cotton waste, or other organic waste. And precaution should be taken to prevent such matter from getting under in or on the coal pile. Second is there shall not be any steam or hot process pipeline or opening or sewer under. There should not be any steam or hot process pipelines or openings or sewers under into through or adjacent to the coal pile. The floor and walls of coal storage bins, if there are, should be non-combustible material. The storage sites should be provided with drainage facility to prevent accumulation of the water on the ground. Special attention to be given to monitoring of coal stack, floor or wall temperature in excess of 42 degrees centigrade. Whenever it is the temperature is more than 42 degrees centigrade, more monitoring would be required. The stack should be planned so that facilitate dissipation of heat by wind from surface of the stack. Any barrier obstruction to the wind should be removed. Newly broken fines of coal are more susceptible of spontaneous heating. Avoid dropping coal from heights. So avoid dropping coal from heights while piling and keeping watch on newly broken fines of coal. So as I told you earlier, smaller is the particle, more is the loss in carbon and hydrogen. There is some background noise. May I know why that noise is? Okay. So as I told you earlier, that smaller particles of coal will release carbon and VM faster, but it will also cause faster spontaneous combustion. So we need to avoid dropping the coal from heights. We need to avoid conical piles. The storage should be built up in layers by roll packing. If you understand, roll packing is good, but normally in bigger power plants, roll packing is being used regularly. This helps to exclude oxygen and thus prevents fire by discouraging spontaneous heating. Never allow coal piles from different sources to be stored together. If you have different source of coal, store them separately. Avoid alternative wetting and drying, keeping one part of pile wet and another part of pile dry. Just avoid that because if this situation arises, it looks especially for spots where spontaneous heating will occur because this moisture also helps in spontaneous combustion. Indranil will tell you more about this. Few more safeguard guidelines. Coal stock should be limited in height. Low grade coal should not be piled higher than 3 meters, and best grade should not be more than 4.4 to 5 meters unless it is piled by using dozer. It is piled by roll packing method. Coal should be stored in mixed sizes as too many fines would be hazardous. Do not allow any standing timber or pipes or poles etc. in the piles. This may give rise to formation of duct, which allows sluggish airflow and may be sufficient for heating the coal, but not sufficient to dissipating the heat. It is recommended to locate the coal yard at least 6 to 7 meters away from important buildings. While selecting the site, it is to be kept in the mind that all part of coal stocks are accessible for regular inspection and monitoring. It should not be like that one part is not accessible and another part is accessible. Consumption of coal should be done on FIFO. This is very important even for spontaneous combustion. Consumption of coal should be done on FIFO, first in, first out basis. Check the temperature of coal pile regularly. If heating has been known to occur, specific attention should be given to the slope sides of the piles where vulnerable air pockets exist, and these are inevitable. The vulnerable coal pile air pockets will exist in these slope sides. So keep on checking the temperatures. If the pile temperature exceeds 70 degrees centigrade, open the pile and place the overhead material in the separate small pile or use it promptly. Inspection of the stack is required to detect smoldering and organize removal or consumption of smoldering coal on the priority and to extinguish flame in time. Such inspections are vital after the rains as water falling on the surface and penetrating the coal pile may aggravate. Coal having high moisture content should be stored separately. If possible, is to be used promptly. These are the three coal stockpile method, and chevron method is what is actually generally used by large power plants. Conical to be avoided. Best is this kind of structure which you see here as a figure 2 B. This is figure 2B. So this is figure 1A, B, C. This is figure 2A, B, C. Figure 2B is the best kind of stockpile which you can make. And here are the literature on the three kinds: winddrawn method, chevron method, and cone shell type method. You may, if you have to blend it out, then winddrawn method or chevron method would be better. Cone shell type should be avoided actually, because that will increase the chances of spontaneous combustion. These are the problems which you face in the coal stack. Stacked coal is unprofitable investment and needs supplement expenses beside various advantages. As a result of oxidation, coking properties and calorific value coal decreased. Oxidation of coal causes an increase in ignition temperature. If the coal is fragile, it will be fragmented. The percentage of small particles will increase. Oxidized coal decreases and the performance of washing plants. Oxidized coal decreases. As a result of storage of coal containing high percentage of methane in closed silo which are not ventilated may explode, but that may not be a case for you. But the most important of these is fire caused by self oxidation of coal. The fire causes the loss of natural wealth and money. The gases formed when the fire are harmful. This is the just normally we face from this coal stack. But we also face some problem regarding GCV balancing. Whatever GCV we are getting as input, say number of trucks into uh, or the kg received into the kilocalories, to convert into gigacalories, and after um 1 month you do a GCV balancing, means what you had, what you got minus what you burnt, and when you see the physical verification, you will find a difference of 500 to 600 kilocalories. And there was a study in NTPC in 5-6 places which Indranil will talk about, and it was a study by CAG of India. So they saw a big difference, huge problems in many of the NTPC plants, having a difference of even 700 kilocalories between what they got and what they burnt or what they charged to the public. So over to Indranil.
Thank you, sir.
Indranil, yeah.
Uh,
So
I will
Indranil,
start. Yeah,
yeah,
tell me, sir.
I'll first uh, stop sharing so that you can start talking on it.
Yes, sir. So I'll be talking about the sampling procedure today itself. Tomorrow we will be talking about
Any
analysis
problem?
part.
Okay.
My
Indranil, before you run in, okay,
Mhm.
I'll just first run the video of that starting of coal in India, and then
Yeah.
we may.
Yes.
Okay. This is a small video. Just will let you know.
India is endowed with a rich variety of mineral resources due to its varied geological structure. Coal is one of the important minerals which is mainly used in the generation of thermal power and smelting iron ore. Millions of years ago, dead plant matter fell into swampy water, and over time, a thick layer of dead plants lay decaying at the bottom of the swamps. Let us
I think we missed something somewhere.
Janaji, what is the schedule for this today?
5:30 till
So,
5:30. If you wanna stop it right now, we can, and we can start this uh, presentation of sampling and analysis tomorrow, because many
tomorrow,
places you are having. Yeah, yes sir.
tomorrow is at what time this seminar is?
Same
Tomorrow
time,
again
sir.
at 2:30.
Okay, okay.
2:30 to
So
5:30.
I think that will be better. We can start tomorrow again, resume this session.
Okay, I don't mind this. If you all allow me, we can do this, sir.
क्या
Because
कहते हो
today
जना
is
जी?
any
ठीक है
questions, sir? Any questions? You can ask. Even Indranil is there with me,
दिन में तो
because
बाकी भी लोग
Indranil.
ज्वाइन कर लेंगे ना, वो बॉयलर वाले.
क्या
हाँ.
हुआ? ठीक है, we'll do it on tomorrow, sir. Manager, and regarding Indranil, I just wanted to know what is the effect of water spraying
Yeah.
on the coal GCV or deterioration.
So if you're spraying the coal on GCV, actually the effect is coming in ARB basis. But if you're analyzing it, or if you're using the coal in a very quick manner, in that case, it is not affecting much. Because if you're analyzing the GCV in ADB basis, then the effect of total moisture is not there. And if you're therefore if you're comparing this GCV in case of ARB basis, then the effect of total moisture are there, and this Water sprinkling is only the increasing the total moisture part, not the inherent moisture. So
Surface moisture.
I don't think there is any effect of water in GCV analysis.
Okay. Any
Okay,
questions?
sir.
In fact, Indranil, just think about the question once again. Okay,
Mhm,
what sir has asked.
mhm,
Okay, Indranil, he has asked what is the effect of water spraying
mhm.
on the coal pile for the quality as well as for the spontaneous combustion. Okay, which I understand correctly. Actually, if you do not do the sprinkling properly, then the spontaneous combustion actually increases due to the moisture percentage. The moisture goes into the void, and later on, the oxygen goes into the voids after releasing the moisture, and then it increases the spontaneous combustibility of that pile if it is partially wetted. And second is if the surface moisture is increased, and if you are measuring through the right standard, to the right method, nothing is going to change. Okay. But if you are deviating from the standard method, because sir, when they are using, when Jubilant company is using imported coal, they must be using ISO or ASTM. So we have to speak about that. In our presentation, currently we are having IS methods. So, sir, are you using ASTM method or ISO method?
Yeah, ISO method.
ISO. So, Indranil,
Okay.
you need to be prepared with ISO method. Okay.
Yes,
The,
yes, that I'm
you have
asking.
to
I have to change
you
the
have to.
presentation with ISO.
No, we have that slide. Don't worry. Okay.
Okay.
Okay. You actually, I was not knowing 100% about which coal is being used, so I took everything in the kitty. But Indranil,
Yes,
frankly
sir.
telling you, whenever we sprinkled water in the coal and the surface moisture increased, and when we do the moisture corrected GCV, at that
Right.
time at that time we find a little bit difference, maybe 1.5% difference in GCV. Is that correct or wrong?
Yes, sir. Actually, we are finding it because of the problem in analysis in inert moisture. See,
Okay.
when we are analyzing the moisture corrected DCV, in that case also total moisture is having the effect as well as the inherent moisture is also having the effect. So
Hmm.
if we are analyzing the inherent moisture without having the constant weight, uh,
Hmm.
that is making the difference.
Yes. Sir,
See,
I'll just take.
what is the significance of this moisture corrected compensated GCV? Moisture
Sir,
corrected GCV?
actually, that is ARB and corrected GCV means what you're firing, what you have received versus what you're firing.
Nee, that I understood. So that is
Hmm.
air dry basis, no?
So
Yeah.
I'm
Hmm.
making it clear. Uh, if you're receiving a coal having a moisture of around 10%, and after keeping it within your stock yard, and it in sunny during the sunny season, it is the moisture is reducing to 8%, and we are firing the coal on having a total moisture of 8. Now if we are comparing apple to apple, the GCV of receive coal is having X at ARB basis, right? At having total moisture of 10%. But if we are comparing the same GCV at fire during firing, uh, something different and having a moisture of 8%, then it is not the apple to apple. In that case, we have to match the total moisture both the cases and find out where is the difference in the GCV.
मैं
This
सर
method is
सिंपल
calling.
नहीं इंद्रनील, क्या मैं पूछ रहा हूँ,
Hmm.
आपके पास में जब आपने कॉल लिया उस समय लेटर से आपका जीसीबी था 5000, लेटर से 4800,
ठीक है,
आपका आपने उसको 6 महीने रख लिया एंड नाउ यू फाइंड दैट उसका मॉइस्चर जो है वो कम हो गया 2% से, एंड उसका जीसीबी अगर हम 2% मॉइस्चर कम करके देखते हैं, अभी जीसीबी देखते हैं तो वो जीसीबी कंपेंसेटेड जीसीबी आएगा, मॉइस्चर निकल गया 2%, उसके अकॉर्डिंग ही आने वाला है वो जीसीबी। ठीक है, अभी अपना जीसीबी का इम्पोर्टेंस जो अपन कोयला आज यूज करने वाले हैं बॉयलर में, उसका इम्पोर्टेंस अपने उसकी एफिशिएंसी के पॉइंट ऑफ व्यू से या उसके एसएफआर के पॉइंट ऑफ व्यू से, ठीक है,
एक्चुअल में
तो हाँ बोलिए सर।
नहीं आप सही बोल रहे हैं सर। एक्चुअल में वो उसी के इम्पोर्टेंस के लिए है। एक्चुअल में हम लोग वो जीसीबी जो है मॉइस्चर करेक्टेड जीसीबी स्पेशली सिर्फ इसलिए देते हैं जिससे कि हीट रेट मतलब बॉयलर एफिशिएंसी और हीट रेट निकाला जा सके।
करेक्ट, मतलब
और
हाँ,
कोई
अननेसेसरी
और कोई
इसका इम्पैक्ट
और कोई सिग्निफिकेंस नहीं है सर।
करेक्ट, दैट इज व्हाट आई वांटेड टू से। यस
हाँ सर, एक 5 मिनट और लूंगा सर आपका।
बताएं।
एक छोटा सा चीज बताने के लिए कि हम लोग वेदांता में और बाल्को में ये कर रहे हैं। हम लोग पूरा मतलब क्रेडल टू ग्रेव जो है कोल का मैनेजमेंट देख रहे हैं। तो फ्रॉम सैम्पलिंग से लेकर जैसे इसको हम ICMS कहते हैं, इंटीग्रेटेड कोल ट्रांसपोर्ट मैनेजमेंट सिस्टम। कोल ट्रांसपोर्टेशन माइन से लेकर उसके अंदर उसका ऐश बनने तक और ऐश डिस्पोजल तक हम उसका पूरा ध्यान रखते हैं। उसके सैम्पलिंग में भी हम लोग क्या करते हैं कि एक टैगिंग बनाते हैं, और वो वो बारकोड रहता है या फिर आपका QR कोड रहता है, जो कि सिर्फ हम ही उसको वो कर सकते हैं, बता सकते हैं कि किस चीज का है। और वो सिर्फ प्लांट हेड के पास और प्लांट हेड जिसको डिजिग्नेट करता है उसके पास रहता है। और ये पूरा जो है ना कोल एक ऐसी इसमें से जाता है जिसमें कि बीच में कोई भी आदमी ना तो सैम्पलिंग में, क्योंकि सैम्पलिंग में भी हम ऑगर यूज करते हैं, कल ऑगर के बारे में भी हम बताएंगे। सैम्पलिंग में हम ऑगर यूज करते हैं। ऑगर यूज करके मतलब उसको सैंपल को इस प्रकार से भेजते हैं कि उसके आईडी वो कहाँ से आया, किस सोर्स का आया, किस ट्रक का है, किसी को नहीं पता चलता है। तो ये हम लोग ने मतलब बड़े ऑर्डर्स तो लिए हैं, छोटी जगह पे कहीं काम नहीं किया है। तो ये भी हम आपको भेजेंगे सर, ये स्लाइड्स आप देखिएगा। यदि आपको यूजफुल हो, जैसे बाल्को में आप पूछ सकते हैं हमारे बारे में कि ATS नाम से हम काम करते हैं वहां पर।
ओके,
एक कायोस्क रहता है, फिर हम ड्राइवर का रिकॉग्निशन करते हैं। ड्राइवर दारू पिया है कि नहीं वो भी हम लोग रिकॉग्निशन करते हैं। लॉजिस्टिक किस रूट से आना चाहिए, किस रूट में नहीं आना चाहिए। डेविएशन होता है तो उसकी गाड़ी बंद कर देते हैं हम रिमोटली, वो गाड़ी चालू ही नहीं कर सकता रिमोटली। मतलब वहां से वहां पर वो यदि उसने रूट डेविएट किया तो गाड़ी वो चालू ही नहीं कर सकता है। कई बार होता है ना, अच्छा कोल डाल के खराब कोल ले आता है गाड़ियां, ट्रक्स। तो वो सब हम GPS के थ्रू करते हैं, और इसको जियो फेंसिंग कहते हैं हम लोग। और और ड्राइवर ने मतलब कैसा है ड्राइवर, ये सब चीजें हमारे हमको वो पता चल जाता है। कौन सी गाड़ी कितनी बार आई, इससे इसको हम SAP इंटीग्रेशन भी किए हैं इससे, और लॉजिस्टिक कमांड एंड कंट्रोल भी किए हैं। SAP से इंटीग्रेटेड है। बॉम्ब कैलोरीमीटर भी SAP से इंटीग्रेटेड है। क्वालिटी डेटा सारे ऐसे SAP से इंटीग्रेटेड है। बड़ी जगह तो हम कर चुके हैं। डोमिनोज पिज्जा भी हमको कहीं मौका दे दे सर तो हम रोज पिज्जा खाएंगे।
अच्छा, एक सब्जेक्ट और है, कोल का
हाँ सर।
इन्वेंट्री कैसे लेने का, उसके ऊपर भी आप अगर थोड़ा बताएंगे तो अच्छा रहेगा।
हाँ कोल का,
फिजिकल कैसे लेने का,
हाँ
कोल
वो
इन्वेंट्री।
फिजिकल
हाँ सर, हम जरूर बताएंगे। हम कल जो है इस बारे में चर्चा करेंगे, या यदि आपके पास अभी समय हो तो इंद्रनील कुछ उस पर बता सकते हैं।
नहीं, अभी अपन विल कॉल इट टुडे एक्चुअली, क्योंकि वो अभी टाइम हो गया बहुत, दूसरा कुछ
हाँ
ऑलरेडी
ठीक
प्लान्ड
है
है
सर।
एक्चुअली
एक्चुअल में हाँ, एक्चुअल में
टुमारो।
हाँ एक्चुअल में 2 घंटे से ज्यादा दिमाग पे प्रेशर नहीं पड़ना चाहिए एक ट्रेनिंग के दौरान भी। प्रशांत सर ने पहले ही कहा था हमको, तो 2 घंटे में ही आदमी एक्चुअली रिसीव कर सकता है, कर लेता है सर।
ये ठीक बोला आप।
ठीक है, चलिए, थैंक यू।
और कुछ आज्ञा हो तो बताइएगा सर।
I think today less people had joined because मुझे पता नहीं था कि अपना दूसरा यूनिट्स आज due to Ganesh Chaturthi they are on holiday. I think tomorrow many people will join because today I think only 2 sites had joined. Remaining another 2 sites were supposed to join, they have not joined. So I think tomorrow a lot of people will there. I think a lot of questions also will come up tomorrow. And regarding the how to do the inventory, माने कोल मेरा के पास कैसा हम लोग मेजरमेंट करते हैं उसका थोड़ा सा प्रोसीजर बता दीजिए tomorrow.
Means sampling and
ना
analysis.
Sampling analysis, that thing you are taking care of.
PV.
Physical verification of coal.
Okay.
ইন্দ্রনীল স্যার ওইখানে ছিল রে, আমাদের হিন্দুস্তান বাজাজের প্ল্যান্টে ছিল স্যার।
আচ্ছা।
হ্যাঁ, তুই এলপিজিসিএল এ ছিলি না আমার সঙ্গে?
হ্যাঁ।
ওই সময় স্যার হিন্দুস্তান বাজাজে ছিল।
আচ্ছা, ওকে।
হ্যাঁ, তুই উড়িয়াতে কথা বলতে পারিস।
Bajaj, it is Bajaj Energy.
Bajaj
Now
Energy.
LPGCL and Bajaj both they have merged and it is now single entity. It is called Bajaj Energy.
Okay.
The smaller units are also into now LPGCL has been merged with Bajaj Energy.
मुझे नहीं मालूम था सर, मैं तो मई 2018 को छोड़ा है ना।
Now it has been merged.
तो इंद्रनील हमारे साथ ही था, इंडिया का पहला ऑगर हमने वहीं पर लगाया था।
अच्छा।
ऑगर सैंपलिंग इंडिया का सबसे पहला इंद्रनील ने ही लगाया था हमारे साथ मिलके। तो एनीवे सर, आज का दिन कॉल ऑफ करते हैं और जो है मैं रिकॉर्डिंग बंद करता हूँ।
ओके
जी, और हम लोग कल 2:30